Questa è la registrazione della lezione di 6 di ottobre e la registrazione è iniziata un pochino in ritardo. Nella prima parte siamo riusciti a definire che cosa significa una matrice, what means a matrix, what does it mean a vector, and we started some basic operations with matrices. We clarified the product of two matrices, taking the scalar products of row by columns, and we used, now we are going to define the inverse of a matrix. Therefore, inverse of a matrix A means we have to solve the following problem. We look for a matrix B so that A product with B is identity matrix. What is identity matrix? Identity matrix is 2 by 2 matrix having 1, 1 here and 0, 0 here. Have in mind that when you have 2 by 2 matrices, we have the main diagonal of our matrix, which is this one. It is called main diagonal. Therefore, for identity matrix, the main diagonal is 1, 1. The other ends are 0. And we are looking for such matrix. If you find such matrix, this simply means, as in the case of real numbers, if you have A times B equal 1, this means B is A to the power minus 1, or 1 over. In this case, we call B, if B exists, we call B A to the power minus 1, and this is the inverse of A. It is quite simple, quite useful. With the help of our inverse matrix, we can practically work almost as we are working with real numbers. For example, if you have this equation, AX equal B, how we are doing? We say if A is invertible, has inverse, then I can multiply both sides by A minus 1, and then this product, see that this is equal BA, equal identity, but this is identity matrix, identity applied to X. What does it mean? The matrix 1, 1, 0, 0. X, we said we are working with vectors. So if this is a vector, having two components, x1, x2, then let us write x1, x2. It is very simple to see row by column that the result is the same vector x. Therefore, from here you can find x. X is A minus 1b. Can be written in this form. Of course, here we can interpret x and b as vectors. And if we find the inverse of our matrix A, then we can find the solution of our equation AX equal B, in which, again, in this equation, A is a matrix, X is a vector, B is a vector. This is usual 2 by 2 systems. After this, we shall have an. But if we have the inverse, then we can do exactly as we did with real numbers. Is A minus 1 of B. This observation, this is nothing more than small observation, shows the importance of computing inverse of a matrix. Let us see whether or not we can find inverse of a matrix. We shall take, as usually, all our theory shall be practically built and supported by examples, concrete examples. Example. Let us take our matrix A to be 1, 0, 2, 3. Goal is to find, we have to find A minus 1 if it exists. Because we don't know whether or not always this inverse exists. So what we have to solve, we said, this is our matrix, we can say let B is B11, B12, B21, B22. What we have here, for unknown elements, simply have to write our equation. What is our equation? A product with B is the identity matrix. Let us write this. We need A, B equal identity. This is, according to definition, how we look for inverse matrix. And of course, here we can substitute A with this matrix, B with this matrix, and compute first A times B. So what was the rule? Set first row by first column. Compute. This is this by this. Of course, this is B11, because this multiplied by this, 0 B21 is 0, 1 B11 remains B11, gives only this guy. Let us try to find this element. What does it mean, this element? This means always first row by second column. But what is the result? 1 B12, B12, and 0 B22. This is 0. So this guy is this one. Let's take now this element. This means this line by this column. 2 B11 plus 3 B21. Okay. And finally, we have to take the row by this column. What is the result? 2 B12 plus 3 B22. I am leaving you for the moment possibility to check if I didn't make some mistake. As you can say, row by column, this one, this by this one, then we have this by this is this one, and finally this by this is this one. So, what is the purpose? This to be 1, this to be 0, this to be 0, because identity matrix was exactly this one. If I write this equal identity matrix, this will give us component by component. We compare, here we have 1, 0, 0, 1. So what does it mean, this equation? This means that we are looking B such that each component is equal to each component. So we have 4 components, and we can write what does it mean. First, B11 is equal 1. Then we have B12 is this element. This shall be equal to 0. This element 2B11 plus 3B21 shall be 0. And finally, this element shall be equal 1. 2B12 plus 3B22 equal 1. And this is very simple. First two equations represent B11, B12. From the third equation, we already know that this is 1. So from this, find B12 is equal minus 2 over 3. In this equation, I know B11, then I can find B21. B12 was 0, so from the third equation we take B22 is 1 over 3. And now we are ready to find our matrix. Then, what is the inverse matrix? B11, we said this is 1. B12, this is 0. B21 is minus 2 over 3. And B22 is 1 over 3. As always, when we make such calculations, always it is important to check that the product A times B is exactly what we expected, 1, 0, 0. 1, 0, 0, 1. Let us compute. We make here check. This guy by this guy gives 1. This by this, 0, obviously. This by this gives 1. We set this 2 minus 2 over 3 by 3. This is minus 2. 2 minus 2 is 0. And finally, this by this gives us 1. So our check shows that clearly the inverse of the matrix. And this means when we are looking at the matrix, very, how to say, direct approach is simply to write this equation. Given A, you have to find B. This means you have 4 unknown parameters. You have to solve this usually system of 4 equations, and you find all elements of your matrix. This is very, very, how to say, relatively not short way to make calculation. This is long way of calculations, but this is simply exercise for our definition. Okay. I think now, because we have already presented a few operations. This is sum, product of matrices. Now we are speaking about inverse of the matrix. I think with these operations we can, for the moment, stop and turn to another important thing. It's very important to have short calculations. Namely, we shall go to so-called determinant of a matrix. This is something that shall be practically first step to clarify when you look, for example, inverse of the matrix. determinant we are speaking for the moment only 2 by 2 matrices. Matrix. Further, it can be seen this determinant can be defined also for 3 by 3, 4 by 4, and so on matrices. But first, let us clarify the situation, 2 by 2 matrix. So, we have A11, A12, A21, A22 is 2 by 2 matrix. This is a matrix. Determinant in general is a real number. Determinant is number, not vector, not matrix. This is important. The first thing to understand, not to make a mistake, to think that this is something connected with our previous approach. And to understand how the determinant is defined, start with a very simple example. A11 x1 plus A12 x2 B1 A21 x1 plus A22 x2 equal B2. You can see here we have 2 by 2 system in which A, coefficients A, or the matrix A, are given, vector B is given, unknown vector is the vector X, that is X1, X2. We said that the couple B1, B2 defines a vector. This here is also vector, while here A is a matrix. Of course, as we did for differential equations at the beginning, we can write this system in very compact form. 1 is equivalent to writing AX equal B. And therefore, here we have something that is quite simple to basic linear equation for real numbers. The only difference is that here it is 2 by 2 matrix, X is a vector, and B is a vector. In this case, we are vector columns. Okay, how we can solve it? There is very simple way to solve it. For example, to find the x1, my plan shall be the following. I multiply, the manipulation shall be the following. Multiply this equation by A22. This equation I shall multiply by this guy, A12. Then we shall take the difference. What happens? If I multiply A12 by A22, and then subtract A22, A12, this is the coefficient in front of x2. So if I difference here, practically I shall cancel x2 and shall find the equation for x1. But what is this equation? We said the equation by A22, second by A12, and then we take difference. So we have A1, A22, x1 minus, here we have A21, A12, x1, and for x2 we already observed this magic cancellation, A12, A22, minus A22, A12, this is 0 in front of x2, so we can write equal B11, B1, A22 minus B2, A12. And as you can see in the left-hand side, take x1 in evidence, and here we have this expression. In front of x1, we have this expression, a real number, of the determinant of A. This is very important because if this determinant, this real number, is not zero, I can solve this equation and I can find x1. Similarly, I can proceed for x2. Always this coefficient is important. Therefore, on the basis of this simple calculation, we can say determinant of this matrix, this is our definition, determinant of A is simply this minus this by this. So we take product over the diagonal minus, this is called anti-diagonal, minus the product over anti-diagonal. So we have A1, 2 minus A1, 2, A2, 1. This is our definition of the determinant, and this is important to compute the determinant and then to see that this coefficient in natural determinant in natural way appears in the system of linear equations. Okay, now we have some very important property. As usual, we take an example and then make conclusions. In our basic starting point, we had 1, 2, 3. What we can say about the determinant of this matrix? How is computed? We use this definition and say this is 1 times 3 minus 2 times 0. The result is 3. So this is very important that this is not 0. And in our previous example, we also found a minus 1 was, if I am not forgetting, not mistaken, this was minus 2 over 3, 1 over 3. Please to check if you have some, if this exactly this inverse. This was in our previous example. It seems this was our inverse matrix. As you can see, this number 3 is not additional because it appears in the denominator when we compute the inverse matrix. Therefore, inverse matrix is computed for the case when determinant is 0. Okay, let us take another example of determinant. What you can say about determinant of this matrix, 1, 2, minus 2, 4. What is the result? We have this by this minus 4. This by this is minus, but we have to take minus this by this minus this by this. Then minus 4 becomes plus 4. Minus 4 plus 4, this is the result, is exactly 0. Question: can we find the inverse in this way? Because we have doubts that this number, if appeared in some denominator, we have big problems. Let us try to compute inverse of this matrix. So we have the matrix A, this one. and we are looking for matrix B. So we have to take this guy, 1, 2, minus 2, minus 4, multiply by B11, B12, B21, B22. We are looking for such matrix, if we are looking for inverse matrix, such that this product is 1, 0, 0, 1, identity matrix. Let us write, as we did in our previous examples, let us rewrite our equations. We have, now we are writing very rapidly the equations because they are obtained taking this row by this column shall be 1. So we have B11 plus 2B shall be 1. This by this is this. Then we have this by this. This means B12 minus plus 2B22 equals 0. Next equation, this by this. So we have minus 2B11 minus 4B22 this by this equal 0. And finally, we have this by this. So minus 2B12 minus 4B. Oh, this is 2, sorry. B22 equal 0. Let us check if I didn't make some mistake. So I take this row by this line is here. This shall be 1. This by this shall be B12 plus 2 shall be 0. This by this is 0. And this by this shall be, this is my, this has to be 1. Because last element, this by this is 1. Let us see how we can treat this equation. First, I can simplify it, because as you can see, if I multiply this by minus 2, if I divide by minus 2, I shall have here plus 2. This is the same. The same thing here. If I divide by minus 2, I shall have here minus 1/2, but here we shall have plus 2. Can we have solution? We have serious problem. Why? This line. B11 plus 2B1 is 1. The third row says us something different. So 1 equals 0. There is no solution. For no solution. This means it is not always possible to find the matrix. It is closely connected with our determinant. If determinant is 0, then we shall have problem to find the inverse of the matrix. If determinant is not 0, then you can solve and find your inverse matrix. This conclusion we have to write officially as important property. If determinant of A is not 0, then A minus 1 exists. one can show also the inverse property. If inverse exists, then determinant is 0. And this is fundamental property that we shall use in our exercises. And to finish with properties without proof, let me mention the following property, without proof, of course. This is property 1. And property 2, that is also very useful for calculation. If you take A times B, we know A is 2 by 2 matrix, B is 2 by 2 matrix, and when you compute determinant of the product, this is simply determinant of A times determinant of B. Can be computed explicitly. You plug first compute A times B, then you compute determinant. You go to the right-hand side, compute determinant of I, determinant of B, and say directly that they are equal. But we shall not do this check. Simply shall write these two important from which we easily find, because if A minus 1 inverse exists, this is identity matrix. So if I take and apply the property 2 when inverse exists, I can say determinant of A times, I apply the rule that determinant of the product is determinant of this per determinant of this. Determinant of minus 1 equal to determinant of the identity matrix. But identity matrix will over the diagonal has 1, 1, and therefore its determinant is exactly 1. And from here we can say that determinant A minus 1 is nothing else than 1 over determinant of A. This explains why, if this exists, then this denominator shall be 0, because you look here. If this exists, the product is 1. Therefore, this shall be not 0. And in this way, we can say that to find the inverse of a matrix, this is very important and useful, especially when you try to solve this equation AX equal B. Remember this example. We started, this is from high school. A to matrix, X is X1, X2, B is B1, B2. When A is invertible, you can simply write X is A minus 1, compute minus 1, applied to B. This is the unique solution of your system. With the inverse matrix, you can do this when determinant is not 0. Now, I think to stop the registration, registering, to go outside for 1-2 minutes, and immediately after this, in order to have 2 short movies, as was suggested for lectures online, not to have very heavy, long lectures. So I shall stop now. And in 1 minute, we shall continue first with your questions and then with the second part of our today devoted some basic notions of linear algebra. Okay, let me stop.